This video is for the Unit 4 study guide. Starting off by looking at Learning Target 1 and Learning Target 2, where we have to provide information about or graph quadratic functions without the use of a calculator. So we're going to start off down Learning Target 2, questions number 3, 4, and 5, as we look at the three different forms that we covered. First of all, question number 3, the function y equals negative x squared plus x plus 3. This is an example of standard form of a quadratic. Number 4, y equals negative 2 times x plus 1 squared plus 5. This is an example of vertex form. And number 5, 1/2 times the quantity x minus 5 times x plus 3. This is an example of intercept form. Now in each of these values, the direction is affected by our plus and minus in front of our a value. That is consistent throughout all three forms. So number 3 is negative, so the graph opens down. Number 4, the a value is negative, so again the graph opens down. And number 5, our a value is positive, so the graph opens up. Dilation is affected by the actual a value. In number 3, it's negative 1, 1 being that we have a standard looking quadratic. A value of 2 meaning that we have a stretch in terms of the quadratic, a vertical stretch. And a value of 1/2 meaning we have a compression on number 5. Now, in order to figure out the axis of symmetry, we essentially need to figure out the vertex first. We talked about how equation number 4, or ideas of vertex form, is the most user-friendly to graph because it gives us the vertex. So in 4, we have the vertex at negative 1, positive 5. It is given to us as the opposite x value and the same y value in our equation. Now with the other two, we have to do a little bit more work in order to find the vertex. We'll start with 5, doing an intercept form. Here we're going to do a quick sketch of the graph. So looking at the equation in a makeshift graph, we know from the equation that m is equal to 5 and n is equal to negative 3. We take the opposite values. These we can interpret as our x-intercepts of the graph, so 5 and negative 3. If we're looking to find the vertex, the h value is found in the middle of these 2 points. So counting my way to the middle, we find that we have an h value equal to 1. As from negative 3 to 1 is 4 units, and 5 to 1 is 4 units. To figure out our k, we are going to simply substitute this k value into our original equation wherever we see an x. So that gives us 1/2 times 1 minus 5 times 1 plus 3 instead of 1/2 x minus 5 x plus 3. Simplifying this down gives us 1/2 times negative 4 times 4, or 1/2 of negative 16, which is negative 8. So we now know the vertex is at 1, negative 8. 1, negative 8. Now this is the approach that we would use in terms of graphing this. Again, we don't graph in intercept form other than giving us our two x-intercepts. From there, we use this information to turn it into vertex form, essentially by finding the vertex, and then we can use our normal quadratic pattern to graph from here. So let's take a look at question number 3 then, where we're given it in standard form. How do we determine the vertex from standard form? Let's take a look at our equation a little bit more in depth. If we're trying to find hk from standard form, first we're going to go ahead and identify all of the values. A is equal to negative 1, B is equal to 1, and C is equal to 3. Only useful information here being that we know C is the y-intercept, 0, 3. So to figure out what h is equal to, we have a formula to help us find this. And that formula is h is equal to negative 1 times b, all divided by 2a. So substituting our known values and simplifying, we get an h value of 1/2, or 0.5. Now, just like before, when we were simplifying in intercept form to find the k value once we know the h, we simply resubstitute into our original equation and find our k value. So we will do the same thing here. So we substitute in negative 1 times 1/2 squared plus 1 times 1/2 plus 3. We start with the exponents. 1/2 times 1/2 is going to be 1/4. And doing our multiplication next, we get negative 1 times 1/4 is negative 0.25. Plus 1/2 times 1 is just 1/2, 0.5, plus 3. So adding these all together, we get a k value of 3.25. So substituting this in, 0.5, 3.25. Now the axis of symmetry just goes through the x value of the vertex, so our axis of symmetry is going to be equal to the x value or the h value of a vertex here, as you can see. Now, this is all just filling in the various pieces of information, not actually requiring the graph, but notice we use the idea of graphing and doing all the math off to the side here to figure out our vertex. All of this could easily be translated over to actually putting the graph together if we were following our normal quadratic pattern. So we're going to go ahead and do that on number 1 and number 2 here. Starting with number 1, where we see this is actually in intercept form, written as -1 times x plus 0 times the x plus 4. And number 2, we see this is written in standard form, where our a value is 2, our b value is -8, and our c value is equal to 6. So, figuring this out from here, we're going to need to plot on number 1 to figure out our vertex and work our way to the middle, and then resubstitute in to find the value of h. On number 2, we are going to have to use our formula to find the vertex value of h and k, h being -1 times b over 2a, and then substituting in back into the original equation to figure out our value of k in each of these cases. So essentially the same math that we did down on these two examples, we're going to have to go ahead and do for example 1 and example 2 here, and then fill in the various relevant information. Now remember, when we do our graphing, we're following the quadratic pattern of x squared. So when I go left and right 1 unit, 1 squared or -1 squared is +1, 2 or -2 squared is +4, and 3 or -3 squared is +9. And any a value that we have other than 1 will affect our y values, either stretching or compressing this vertical distance. All right, the x distance will stay the same. 1, 1, 2, 4, 3, 9 may change, but the 1, 2, and 3 will definitely be the same each individual time. So looking back over at these, let's take a look at example 1, graph number 1. I plot my x-intercepts, count my way to the middle to find the h value of -2, substitute it in, I get a k value of 4, and then following the quadratic pattern with a negative a value, I see the graph listed here. And in number 2, substitute using the formula h equals -1 times b over 2a, we find an h value of 2, and substituting the k that in to find the k value of -2. Following the quadratic pattern here affected by the a value of 2, I go over 1 up 2, over 2 and up 8 in this case, and that gives me my graph that's listed here. And we can fill in all the relevant information from this and these two graphs.